Good evening, students. Yeah, so I'm requesting you just turn on your camera. Okay. So first step in any machine learning pipeline or data science life cycle, the first step is understanding of the business problem statement. So again, I'm repeating the problem, repeating with the first step. So let us assume you are working for an XYZ company. For that XYZ company, the client is a MGM hospital. Now that MGM hospital gave a problem statement to your company, and that problem statement is they are asking a AI based application, that may be a web application or that may be a mobile application, to diagnose the COVID based on some features, some symptoms. So before all, to avoid the crowd. So to avoid the crowd at hospital premises, so they want to develop a web application or mobile application to diagnose the COVID based on some features, some symptoms. So if that application suggests that there may be a possibility for a COVID, then the person, they may go to the hospital for the remaining process. So that will be helpful to avoid the crowds at the hospital premises. Okay. So I hope you understand the problem statement. So now the company gave the problem statement to you as a developer. So first of all, you have to understand the problem statement properly. So what is the problem statement? The first one is you have to build a web application or web application, mobile application, to predict whether the person have a COVID or not, to predict the probability or possibility whether the person has a COVID or not based on the some features, right? That is the problem statement. That is the first thing you have to understand. Yeah. So once you understand the business problem statement, then you have to work with the data. Now you have to work with the data. In the data, so first step is feature engineering. Feature engineering means you have to collect the various you have to collect the data for that application. So then what we will do, you go to the hospital and you met the doctors or hospital managements and collect what the data they have, historical data they have. That means they may give the previous patients who visited their hospital, they give the data. So they give the data, that data may contain, so the data that may contain date, time, and the patient ID, and like say fever, whether you have the fever, how much, whether you have a cough or cold, whether you have the cold or not, what is the oxygen level, what is the pulse rate, and what is the labeling. So finally, whether the person has really diagnosed as a COVID or past data. Okay, like assume at a particular date like 20/09/2020 at 5 p.m. one patient with ID1 joined, and he had a 1 or 2 fever, some COVID is cough is S, oxygen is very less, pulse rate is very high. So then it will be a positive. That means it's a positive. So such type of data he will provide. You have to collect the data. The first thing is you have to collect the data, and you have to observe all the features. What are the features are there in the data? So that's called as the feature engineering. Identification of the features, all those things. So that's called as the feature engineering. Feature engineering you have to work on it. So after collecting the data, you have to work with the feature selection. They will provide the vast data, not only single sample, they may provide the thousands of samples data, they will provide thousands of sample data. From this vast data, so you have to work on the feature selection. So feature engineering means taking all the possible features, what are the possible data, what are the possible features are there. You have to collect all the features to predict something. To predict something, what are the possible features? You have to collect all the features. So after that, you have to go to the feature selection. So feature selection means among all the features, which features may have the huge impact on the prediction. Which features will have the huge impact on your prediction, on your application. Like, so if you want to diagnose the COVID or not, whether the person has the COVID or not, to diagnose this thing, do you think all these features are required? Do you think all these features are required really? No, it's not required, right? You no need to date label. You require a date column to diagnose the COVID? No. The time column is required? No. A patient ID is required? No. So you can remove those things. You can remove some of the features and you can select some of the features which have the high impact on the your prediction. So like patient symptoms like fever, cough, cold, O2, pulse rate, whatever it may be, which will have a most impact on the COVID. Those things you have to use as a main feature. So during the feature engineering, during the data collection, you may collect the thousands of samples of data, and that contains the tens of columns, tens of features. That's called feature engineering process. But later, all these features may not required. All these features may not required. So you have to select the most appropriate features for your application. So then what you have to do? You can't do yourself, right? You can't select yourself which features are more appropriate for your application. So you have to meet your domain expert. You have to meet your domain expert. So like doctors. So meet, consult with your doctors, and you have to tell which features, based on which features we can predict whether the person has a COVID or not. Which features are more appropriate to diagnose a disease. So based on the doctor's opinion, you can choose the proper features for your application. That feature selection you have to do. So these all are data operations. Now fine. So among 1, 2, 3, and these are the 8 columns, 8 features. 8 features means this is the feature 1, feature 2, feature 3, feature 4, feature 5, feature 6, feature 7, feature 8. 8 features. This is the output label. It's a target column. It's not a feature. It's a target column or label column. The last column is a label column or target column. The remaining 8 columns are the feature columns. So among all available features, how many features you want to use for this prediction? So I want to use only these 4 features, 5th feature, 6th, 7th, and 8th. These 5 features I want to keep for my application development. So you have to identify the features which are most appropriate feature for your application. So now what the data? Previously your data size may be 1000 by 9 columns. Out of 9, 1 is the label column, remaining 8 is the feature column. Now this data is compressed to 1000 cross 1, 2, 3, 4, 5, 6 columns. Because these 3 columns we are ignoring because these labels, these features don't have any impact on your COVID disease, date, time, ID, patient ID. That doesn't have any impact, not appropriate for the COVID diagnosis. So now, after feature selection, after some feature engineering, finally we have these data, 1000 rows data, 1000 samples data with 6 columns. Out of 6 columns, 5 columns are the input features and 1 column is the label column. Hope you understand up to now. Right? Now data is ready. Now data is ready up to some level. Okay. Now in this available data, so we have the 1000 rows and 6 columns data. In this data, you have to identify for the any values, any feature values are missing. That may be a possibility because it's human error. It may be a human error. So while taking the data from the patient, there may be a possibility some features for some samples, some features may be missed. Null values. There is a possibility for the missing value. If there is any missing value, so you have to treat the missing value. You have to treat with the missing value. Hope you understand, right? So you have 1000 samples of data. So 1, 2, 3, 1000 samples of data, and each sample you have the 1, 2, 3, 4, 5 features, input features, and 1 label column. Okay. So among all the 1000 samples, there may be a possibility missing of some feature values. Some feature values, there's a possibility missing of some feature values. So you have to identify if there is any missing value against each feature, against a fever, against a cough, against a cold, against O2, against pulse rate, or any values are missing. So you have to identify. If there is any missing values are there, you have to treat the missing value. So treat the missing value. One of the methods treating the missing value is if there is any value of the feature is missing, then you have to remove that complete row. That is one of the strategy. That is the one of the strategy for the missing value treatment. But don't rely on this strategy. Just to only to make you understand, I'm telling this removal of the row. Okay. Suppose if there is some other feature is for another sample, 1,000 sample, let us assume there is a feature corresponding to the O2 level and a value corresponding to the pulse rate are missing. Then what we will do? Just remove that row also. So make sure that in your data there is no null value, there is no missing value data there. So that is called missing value treatment. But this is not the right solution for the missing value treatment. Just to make you understand, I am suggesting this one. Why it is not a right solution? Because if you remove the rows continuously, then your data will be, the data size will be reduced. The number of samples in the data will be reduced. Your model, you can train model well only if you have the abundant of data, a large amount of data you require. If you reduce the data, then your model may not learn properly. Okay. But it's okay. There is another case. Don't bother about that one. As of now, what we have to understand is once you collect the data after feature selection, you have to identify for whether there are any missing values are there or not. If there is any missing values are there, you have to treat the missing values. So treatment of missing values are like removal of the row corresponding to that feature value, removal of the row corresponding to that feature value. Okay. Or there's some other fashions, like sometimes we are imputing the missing value with the mean values. So imputing the missing value by mean value means let us assume this is the favor column. In the favor column, in one row we have the 102, 98, 97, one value missing here, some is 98, like that. Let us assume. So if you want to impute this missing value, then what the one strategy you may impute, you can replace this missing value with the average of the remaining all values. Calculate the average between all these four values and replace that value here. That's one of the missing value treatment. But don't rely on, just apply your common sense. Just apply your common sense. So these are the different strategies, whether this strategy is good for your application or not. Okay, that you are looking at the real applications, you have to think whether this is appropriate or not, or I can impute that missing value with a mean value, or I can remove that row completely. That is based on your common sense, based on your application. So like that, you have to identify the missing values and also treat the missing values. And in addition to that, there are another thing is outlier treatment. So outlier treatment, what mean by the outlier treatment? So what is the outlier treatment? So outlier treatment means, so for every feature, some set of values are there, right? So because of the human error, there may be a possibility wrong data may be entered. Previous one is data is not entered, but now if it is the wrong data is entered, how we will work on it? How we will work on it? That's called outlier treatment. That means, let us assume there is one column called favor, right? We have the one column, one feature called favor, right? There is a different samples, let us assume 102, 98, and 98.6, and that may be 99.3. So do you think any human body has a temperature of 98.6? No. So that type of values are called as outliers. So that may be 98.6, but because of the human error, they may forget to write the dot. Because that one it looks like in 98.6, 986. So you have to identify such type of that's called as outliers. Generally, favor range will be something like that. So we are getting some abnormal values. We are in the data. You can find some abnormal values. Those are called as the outliers. So you have to treat with that outliers. How we will treat that outlier? If you found such type of number, again you may remove the complete row. That means you can remove the complete row. That's the one option. Or you may consult with the doctor. So what it may be, or you can apply your common sense. So maybe the dot is missing here. So it will be the 98.6. So you have to treat the outliers also. Okay. So I hope you understand. First thing is problem statement understanding, problem statement understanding, and second one is data processing. Second one is data processing. Data processing means collection of the data, feature engineering, and also you have to do the missing value treatment, and also you have to work on the outlier treatment, and also you have to work with the you have to do the normalization also. Sometimes normalization also required. So what is the need of normalization? What mean with the normalization? What is the need of normalization? So now see, suppose your features are fever, cough, cold, and your O2 level and your pulse rate. Okay. Now you can observe your fever will be in terms of between the 90 to 105, 110 like that. Let us assume. Okay, these values are between 90 to 110. And cold cough means yes or no. Cold and cough values are yes or no. Generally, your machine will not understand the words. So we have to convert that words into the numbers. So I want to represent this yes as 1, no as 0. Now your cold column will contain 1, 0, 0, 1 like that. And your cough column and also cold column will be like 0, 1, 0, 1 like that. All the values are 0 and 1. Similarly, oxygen levels and pulse rate also some number values. But see, it is a random distribution of the data. So these are the some numbers of tens and these are the 1 and 0s. So there is a high domination of the sum of the features on your prediction. This is the label that you want to predict. Like COVID, if it is a COVID, it is a 1. If it is a not, it is a 0. If it is yes or no. If it is S1, if it is no, it is a 0. So there is maybe a domination of the few features on the prediction of your label because of the huge amount of data. Sorry, huge values, larger values when compared to the remaining features. These values are 1 and 0, and these values are in terms of the tens like that. So because of the higher value, they may be biased towards some of the features. There may be some features will be dominated on the prediction. Then what you have to do? You have to do the normalization. Normalization means you have to make all your features between the range of 0 to 1. So keep all the features in the same scale. You have to keep all the features into the same scale. That may be required some applications. So you have to do that also. So that all the things are called as the data processing. So once after all these processes are happening, so finally your data may consist like this. Your data may consist like this: fever, cough, cold, O2, and blood pulse rate, and your column label. And here maybe something index or sample number, they may exist sample number. So first sample, you have the some values. And second sample, you have the some other values. So like that, you have the 1,000 sample, you have the some values like this. Now final data is ready after all the data processing. After all the data processing, now data is ready. Now you understood the problem statement. Now you have the data ready. Now what the next step is? So your next step is you have to so once you data is readily available, now what you have to do is based on the identification of your problem, your observations, our analysis on the problem statement, based on the available data, you have to think which type of machine learning model is required, which type of problem it is. You have to identify which type of problem it is. Now, if you observe here, it is a binary classification problem because you are going to predict a label which value is either 0 or 1. So it is a binary classification problem. So you have to identify which problem it is. You have to identify which problem it is. So once you identify the problem, and you have to choose a proper machine learning model to get the solution. Now, based on this analysis, we understand that the given problem is a binary classification problem. So if we have a binary classification problem, we may go with a logistic regression model. We may go with the logistic regression model. So your third step is you have to identify type of problem. And next step is the fourth step is you have to choose proper machine learning model. You have to choose proper machine learning model. Yes, you can also do the data visualization. That is only for the purpose of the presentation and also for the understanding. Because data visualization will be helpful sample distribution. You can visualize the data. So here also you can do the data visualization. So in the data visualization, what you can understand is you can visualize the how data is distributed. So that data visualization is not mandatory, but if you have a data visualization, if you visualize the data, you may overcome some of the problems which will appear in the future. Like during the data visualization, you can visualize the data, like how many samples of data corresponding to the COVID positive and how many samples of data available corresponding to the COVID negative. Such type of visualization, you can visualize the data, and you can observe whether this data is balanced or not. So balanced or not, your data should be balanced. So that can be observed based on the data visualization. Of course, without the visualization, also by using some programs, also you can observe that also. Data you can, and moreover, and you can find which type of machine learning model is more suitable for your application. That also you can observe. Like see, actually, if you go for the logistic regression model, so it will be like this. So it will be 1, that means COVID positive. Here values are 0, this is a COVID negative. Okay, if your positive samples are distributed like this and negative samples are distributed like this, then you may go with the logistic regression model, because your model is able to separate these two clusters, these two groups, easily classify these two classes easily. Okay, if there is highly complexity, you may go with for the high complex machine learning models. Agree? So you may use the data visualization also. So if you have the data visualization, you will get some more conclusion towards which type of machine learning model is suitable, because you identify the binary classification problem. The binary classification problem can be solved with a logistic regression model, descent tree, or random forest, or ANN. Okay, but among these three, you want to try with all the machine learning models, and later which machine learning model performs well, you want to use it for the deployment. If that is the approach, it's fine, no issue. But if directly want to go with a proper machine learning model, so then you may go with the data distribution observation. If the data distribution observation is like this, then yes, you can a logistic regression model easily classify these two groups. Easily separate these two groups. Then you can. If it's some more complex means there may be some of the negative samples also there here. If that is the case, it's somewhat difficult by using the simple logistic regression model. That's fine. As of now, it's fine. So if you have the data visualization, you can visualize the data whether it is balanced or not, and also you can visualize the data how it is distributed, and from that you can conclude more appropriate machine learning model for your application. So that's so. Without this also you can proceed, but you have to work more, and there may be some problems occur in future at a later part of your application. So you have to identify the problem, and you have to choose the proper machine learning model. So once you choose the machine learning model, what you have to do? So before that, actually there is one more step. During the second step also, there is one more step we have to do. Any idea? Apart from what are listed here, and apart from what one of your friends suggested, data visualization, is there any other step is required at the second stage? At the second stage, is there anything I missed here, or anything I have to add at the second step? So that is called as splitting the data. So one step I have missed here, that's called splitting the data. You have to split the data. So data is after normalization, you have to split the data. Why we need to split the data? Generally, I want to go with our generalized discussion. It is a machine learning. How actually human learning is going on? How the human learning is going on? Please tell me how the human learning is going on. Initially, as an instructor, I will train you on some content, on some data, that is the training. So once the training is over, I want to test you. I want to test you on the what I delivered on that course. I want to test you. So in the human learning, we are using the two phases. One is called as training, another is called as the testing. Training and testing, right? So when let's assume you are studying some C language course in your first year. So it may contain 5 units. So then what happens? The 5 units, the contents are called as data. So based on the data, you are the machine. You are the natural machine. You have the natural intelligence. And the instructor trying to make you learn on that content, on that data. Then what you will do? So on that data, he will train you and he will give some more questions to test you. So during the assignment, as an assignment purpose on classroom, he will give some problems to you. He will explain some problems to you. Where in the testing stage, he may give some more new problems to you to test yourself. How much you learn to test yourself, to test you. So he will give some more questions, right? That means the content, the questions that what he has. So some questions he will give you during the training stage. He will demonstrate you during the training stage. He will demonstrate you during the learning stage. Okay, once the demonstration is completed, then what happens during the testing stage? So he will give some more questions, some new questions to you, some new questions to he will give, and you will check how you understand that course. So the data, those contents is separated, some for the training and some for the testing. So here also same process. In the machine learning also, once you identify the machine learning model, that may be a logistic regression model or decentralized random forest, whatever it may be, once you identify the machine learning model to train that machine learning model and also to test that machine learning model, so you have to split the data for the training set and for the testing set. So you have to split the available data for the training purpose and also for the testing purpose. There is you have to split the data for the training and testing. The splitting data is required. Generally how data splitting is done? So data splitting is done randomly, not data splitting is done randomly. That means if you have the 1,000 samples in the data, so don't think that the first 900 samples goes for the training and remaining 100 samples goes for the testing. It's not like that. The splitting of the data row wise, not column wise, students. Out of the 1,000 samples, it will choose any 900 samples for the training purpose and remaining 100 samples for the testing purpose. The splitting of the data for the training and splitting of the data for the testing. So that is done randomly. Students, why I am asking again and again, because you will get this type of questions in your examination. So like, but for that there is a method called train underscore test underscore split. Some methods are there. So this is some inbuilt methods are available, and those methods will help you to split the data for the training and testing. So the splitting of the data for the training and testing is done randomly, row wise, not column wise, not column wise splitting. It is row wise splitting. That means 900 samples, 900 rows selected for the training and remaining 100 rows are for the testing. Which 900 rows will be selected for the training? That can be done by randomly. So you will get the questions how we split the data for the training and testing. So data will be split for the training and testing randomly. Okay. And second thing is make sure that there is no duplicates. That means what are the data separated for the training and what are the data splitted for the testing. There is no duplicates in this group and in this group. There is no duplicates. Okay. So that means if there is 900 samples in the training set and 100 samples in the testing set, there is no duplicates between these two. That also we have to take care of that one also. There is no duplicate data. If there is a duplicate data, there is no purpose of conducting the testing, right? If I gave a questions, some questions I demonstrated in the classroom. If I give the same questions during the testing, there is no use, right? Actually, of course, currently we are doing like that. But actually, if really want to test your knowledge, if you want to really understand how the machine will perform in the real time and the new data is coming, then you have to test that model when new data coming. Understand? No? See what I want to tell you is, So during the training phase, I will explain a 10 problems to you. Now it is a testing phase team. So during the testing phase, I give the same 10 problems to you. It's not a right testing. It's not really right testing what you learn. So I have to give some new problems. Then I have to check. I have to really test you how you are working on those problems, how you understand the concept. When the new problem coming to you, how you will tackle that problem. That type of testing is required. Really, in a machine learning model, once you train the machine learning model, if you test with the same data, but if you keep in the real time, don't expect that same data is coming in the real time also. There may be some new values will be coming, right? So that's why you have to test the data. You have to test the model on the data which is not seen during the training phase. You have to test the model with the data which is not shown in the training phase. That's the reason why make sure that there are no duplicates in the training and testing. So clearly understand what I'm saying. You may get the two questions from this discussion. So one question is how samples are splitted for the training and testing. That is the randomly, and why we required. So why we require means one is for the training purpose and also one is for the testing purpose, and also make sure that there is no duplicates, because we are really want to test the model how it will perform when the new data comes into the picture for the prediction. When the new data comes into the picture for the prediction, how your model is performing, how your model is performing. So that is the required. So make sure that those things may, those such type of questions may come in your examination. So you have to split the data for the training and testing. So after that, come to the fifth point. Once you choose the proper machine learning model, now you have to train your machine learning model, and later you have to test your machine learning model. So you have to train your machine learning model with your training data, and you have to test your model with the testing data. If you are happy with the both training error and also testing error, don't expect zero error. Don't expect zero error. So your error should be as minimum as possible. And that machine model will be that robust. Okay. So you have to test, you have to train the machine learning model and test the machine learning model and observe the training error and testing error. And you have to analyze yourself whether the model is performing well or not, is going to perform well or not based on the errors. Then the different problems like underfitting and overfitting and perfect fitting. You require a perfect fitting. Underfitting means training error is very large. That means it's not fit. Your model is not trained properly. Underfitting means your training error, your error during the training phase is very large. That means your model is not trained properly. That is called underfitting. If that is the case, you have to take some strategy to avoid this issue. Or overfitting. Overfitting means your training error is very, very good. You're almost near to zero, but testing error is very high. So that is called overfitting. But that means on the training data, it's well fitted for your training data. But once the new data comes into the picture, it's not able to predict properly. Testing error is very high. They're called overfitting. So perfect fitting means there's not much difference between the training error is low, at the same time testing error is also low. There's not much difference between your training error and testing error. That is called perfect fitting. So if you make sure that your model is fit very well. Make sure that your training error and testing error is as low as possible. Okay. So once you are happy with your performance of the model on the existing data, with the existing data you trained and you tested, and you feel that it is performing well, and you have to deploy that your model, deploy your model for the real time. You have to deploy your model for the real time. Okay. So these are the steps that we are generally following in the machine learning pipeline. So before deploying your application to the real time, you have to test it in between. So it is a simulation testing, and also there is some other practical demonstration in front of your client also required. Practical demonstration of your application in front of your client also required. So once you trained and once you tested, now you develop the application. Now you develop the application. In that application, you deploy the machine learning model. Now you have to test that application, which runs behind by a machine learning model. You have to test that application in presence of your client. Once your client is satisfied with the performance of your application, then you will go for the real-time deployment. So like a testing environment and a production environment. Generally in software, it's called as a testing environment and a production environment. So initially, before application go to the production environment, you have to test it in the testing environment. So once you have to test it in the testing environment in presence of your clients, once they are happy, then go for the production environment. So those that is the complete pipeline for your machine learning application development or data science life cycle. So this is all about your data science life cycle. All the things I have listed. I have explained all the things: feature engineering, model training, model evaluation, nothing but the testing, and also data related information and deployment and business understanding problem. So all these comes under the data science life cycle or machine learning pipeline. Now this is about you have the full data set. You have the full data set, and you have to split the data set for the training and also for the testing. Okay, so for the training and for the testing. So make sure that your training data should be much larger than the testing data. ఎందుకంటే మనము ట్రైన్ చేయడం కోసం ఎక్కువ ఇన్ఫర్మేషన్ కావాలి rather than the, because we will train you. See, ఇప్పుడు మీకు ఒక సెమిస్టర్ ఒక సబ్జెక్ట్ ఉంది అనుకున్నామా, ఆ సబ్జెక్ట్ కోసము 5 months time కేటాయిస్తుంది. we spend 5 months of time to deliver the contents available in the subject. So don't choose the huge amount of data to testing purpose also. Because we can't spare 5 months for testing, right? We will spare only 3 hours for testing. That is the reason why we will choose only 8 or 10 questions from the complete content. So that's why your training set should be large and testing set should be as small as possible. Okay, less and training set should be large. And sometimes the training set further divided into 2 portions. One is for the training set and is for the validation set. Sometimes, not all cases. Sometimes you may split further the training set for the training data. You have to split for the training purpose and also for the validation purpose. So what is this one? So what is this validation? So you said the training set and the testing set we understood. So training set means the data which is used for the training purpose, that's the training set, and the data which is used to test the model, that is called the testing set. But what is this validation set? So validation set is nothing but validation is nothing but testing a model during the training phase. Test the model during the training phase. Why we require testing during the training phase? To check whether the training is going in the proper manner or not. Check whether our training process is going in the proper manner or not. Like see, let's assume in your third year first semester you have one subject which contains 5 units, right? Generally, what the strategy we are following in the institution? It's not the strategy, not like we are delivering all the 5 units to you during the complete 5 months semester period. At the end, we are conducting the test. Is it right? No. In between, we are conducting the mid examinations also. Because I hope you understand. So you have the 5 units of data. So we are not completely train you complete semester on this 5 units of data and later to testing. It's not a process. What we are doing, among the 5 units of data, we train you on the first 2 units. We are conducting some mid examinations. Later, we are training you on the remaining 3 units, and again we are conducting the mid examinations. And finally, we are conducting the external examination. These mid examinations like a validation, and external examination is like a testing, and remaining is the training. Okay, so why we are conducting the mid examinations? Because whether you are moving in the proper manner or not, whether you are learning in the right way or not. So we are conducting the mid examinations. So based on the mid examination results, so we can decide what action we have to, whether the training is going properly. If you are performing well during the mid examination, then the instructor will follow the same path what he is following up to that time. Hope you understand. If the results in the mid examinations are not going well, that means there may be a problem with the instructor or may be a problem with respect to the students. So we have to change our training process. Yes, the training is not going well. So we have to change the training process either by changing the instructor or by insisting the student to listen carefully. So some action we can take care. If you're not conducting the mid examinations, you are delivering the 5 hours of course during the semester, finally conducting the test examination, you failed in the final examination, there is no use, right? So that's why we are testing you during the in between the semester, so that your final obstacle will be successfully overcome. You can overcome the final examination successfully. You will get good marks in the final examination. Same thing here also. So with the training data, you start training the model, and with the testing data, validation data, you are trying to test it during the training only. So if there is a much difference between the test training error and validation error, then you can conclude that the training is not going well, because your validation error is very large. Validation error is coming very large. So the training process, what we are going on, is not going in a good manner. So we have to stop the training. Don't wait until the 1,000 or 10,000 iterations. Generally, training will be going for the 1,000 or 100,000 iterations. If you're not using the validation, then what you can do, you can train your model for the 1,000 iterations, and later you will test it. If your model is not performing well, again come back, again train with some modifications. But your time is wasted, right? Because you have to wait until 1,000 iterations are completed. But if you are going with the validation set separately, then you can observe during the iterations, you can observe what is the validation error. So if the validation error is continuously increasing, it is a very large value, then you can conclude that training is not going well. Then you can stop the training in between. Don't wait until 1,000 iterations are completed. Don't wait till 1,000 iterations completed. Don't wait. So you can kill the simulation, kill the running environment at that time, and you choose the proper tuning of parameters, whatever maybe you have to do the necessary action. Then you can train it again. So, but there is no validation set. You have to train the model until 1,000 iterations. Then only you will get the, after that you have to test it. Then you can conclude whether it can back to the again training, or you can go for the real-time production, real-time deployment. Hope you understand, right? So with the validation set, you can monitor how model training is going on. So if you feel that the model training is not going perfectly, then you can kill that run and again do the necessary modifications, again train the model. Don't wait until the last iteration. But if there is no validation set, you have to simulate the model until the 1,000 iterations and test it and compare the training data and testing errors. Then you can conclude whether retraining is required or deployment is sufficient. Okay, so this is about the data splitting. So you have the training data using proper algorithm, proper optimization method. You have to train the model. Once the model training is perfect, now give some new data, some unseen data, and test that model. Compare with the target value. So if the training error, testing error is perfectly right, then you go for the real-time deployment. So again, I'm repeating, with the training data, like a content data, with the proper optimization algorithm, like a strategy. Now train your model. When the model training is over, give some new data to your model, unseen data from the testing data, give the unseen data to your model and calculate the errors and do the prediction and compare with your target value, calculate the error. This is the testing error. The testing error and training error are good, then you may go for the model with the deployment, final deployment. If it's not good, then you may require some more corrections in your model or in algorithm in your data, then you have to retrain that one. So this is how machine learning pipelines are going on. And what are the changes with the AI method, artificial intelligence and machine learning? What are the challenges? Challenges are bias. First challenge is the bias. Your model may be biased towards or against. Your model may be biased towards or against some parameters. That's called as bias. Okay. I will do in detail explanation for the next class when we are discussing about the principles of responsible AI. I will explain about what means by bias in detail. So bias means, suppose while correcting your question paper, if I like one person in your class, then maybe I have bias while correcting. I will do the good marks to him. That's called bias. I was biased towards him. So me class lo oka abbayi ante నాకు ఇష్టం అనుకున్నాం. సో అతను ఎక్కువ మార్కులు వేసేస్తున్నాను అనుకోండి, then I was biased towards him. అలా కాకుండా ఒక అబ్బాయి ఏమో రోజు క్వశ్చన్స్ అడుగుతుంటాడు, ఇరిటేట్ చేస్తుంటాడు, అంటే నాకు కోపం ఉంది అనుకోండి. If I reduce the marks for him, then it's called as a bias against. So there may be a problem of the machine learning model. Your model may be biased towards particular parameters or biased against a particular parameter. So So bias means partiality. It's like a partiality. So we are completely towards one parameter, one person. That's called bias. And errors. So your machine learning model error should be as, don't expect zero. So as minimum as possible. So otherwise, you will face a very, very critical issues. You will get a very, very critical issues you have to face in with your machine learning model, with your developer application. And data could be exposed. There is a possibility. There is a possibility to expose your data. So because hospital, MGM hospital asks you to build an application. So you perfectly developed the application and given to the hospital, and they kept in the production environment, and the patients are using using that application. Innocently, they will give, because they are dealing it. They will treat. They are talking with the doctor. When you are talking with the doctor, we have to open everything. So the patient will give incomplete information to that application. So that's why your data should not be exposed. There is a possibility to expose. So you have to take care of data is very confidential, that is not exposed to third party, to other persons. That also you have to take care. That's also one of the challenge. Solutions may not work for everyone. You develop an application, it may not work for everyone. Suppose you develop one application for the currency note recognition, let us assume. You forget to include the audio output. Then what is the purpose? How the visual input people will get that information? If it is a no audio, how visually impaired people will get that information? So the solution, make sure that the solutions will be may not be work for everyone. So make sure that it will work as much as possible. You can spend as much as possible. It will have the customers as much as possible. Variety of customers as much as possible. Users must trust a complex system. So you develop a complex system for a user, but user will use the complex system only if you believe him, if you trust him, right? If we don't have it trust, then see, during the COVID, I think during the COVID time, I think so, I will get some messages. So there is an application. If you keep your fingerprint on that camera scanner, so it will tell whether the person has a COVID or not. How? There are some people immediately some messages are coming like that. Don't do like that. There is a possibility to mislead your fingerprints. So maybe they developed a complex system, but I have to trust it, right? So that is also required, especially in the AI applications. And who is liable for the AI-driven system? Okay, you developed an AI application, something going wrong. Who is the responsibility? So these all are challenges in the AI. So to address all these changes, there are some principles. So to address all these challenges, you have to build a AI. You are building the AI which is more responsible. Your AI must be a more responsible AI. So what are the different principles of responsible AI? There are 6 principles. You will get some questions, mainly 2-3 questions from this discussion, principles of responsible AI. So we will discuss in the tomorrow's class. Complete tomorrow's class, we are mainly focusing on the principles of responsible AI. So each principle will address each challenge. Each principle, there are 6 principles are there. So here you can see the 6 challenges. So each principle will address each challenge. So we will discuss about the responsible AI principles and tomorrow class. So thank you for your patience learning. I'm going to close the class for today, and we will meet tomorrow at 6 p.m. So if you have any questions, please you can ask to the chat box.